Hey mathematicians, today we are going to talk about how we can solve and graph inequalities. So some information that we need to remember from last year is an open circle means that the value is not included. So when I have x is greater than 2, that means x can be any number bigger than 2, but not 2. So 8, 7, 6, 5, 4, 3 is fine. 2.5 is fine, 2.001 is fine, but it can't include 2. So we use an open circle on that number line to show that we can go all the way as close to 2 as we can, but not include 2. Same thing for x is less than 5. We're going to use an open circle on 5, and we'll color in everything less than that to show 0, 1, 2, 3, 4 is fine, 4.5 is fine, 4.99999 is fine, but we can't hit 5. A filled-in circle means the value is included. So when I have x is greater than or equal to 3, we color in that dot and everything bigger than 3. So exactly 3 works is a solution to that inequality, as well as everything bigger than that. In x is less than or equal to 6, we end up with it's equal to, so we color in and then shade everything that is less than. So 0, 1, 2, 3, 4, 5, and 6 get to be included. Okay, so let's look at number 1. We're being asked to graph x is greater than -4. So we'll draw our number line, put in a 0, put in a -4. That's what we're worried about. X is greater than -4. It is not equal to. So we're going to use an open circle and shade everything to the right. Number 2. 5 is greater than or equal to j. If we wanted to flip these and have them trade places, we could say j is less than or equal to 5. Notice how the open end is close to the 5. The open end is close to the 5. So you got to make sure that the bigger end stays by the same number if you're going to flip them. So this tells me j is less than or equal to 5. I'm going to set up my number line. And you'll note I'm not including every single number on my number line. We don't need all the numbers. I do need 5 because that's what j is being compared to. J is less than or equal to, so since it could be equal to, we'll fill it in and shade everything to the left. Okay, number 3 tells us to graph 4 is less than r. If you wanted to flip them, you could. You could say r is greater than 4. Go ahead and draw your number line. Decide where your circle goes and whether or not you fill it in. Pause here, come back to check. So you can see here we left an open circle on 4 because r is greater than but not equal to, and we shaded everything to the right because r is greater. And our next problem is p is less than or equal to -3. We don't need to flip them because the variable's already on the left. So get your number line set up and decide where your circle is going to be, whether you're going to fill it in and which way to shade. And pause here, come back to check your work. You can see here that I went ahead and shaded in my dot on -3 because p could be equal to -3. It also includes all the values that are less than -3, so I shaded everything to the left. So that was a review from last year. Now we are going to work on some new to us material. We've got 6x is greater than or equal to 24. We are going to treat this just like a one-step equation. Draw a line through your equal sign, and we are going to do inverse operations. So we're going to look for subtraction and addition. I don't see any, so let's do division and multiplication. I'm going to divide both sides by 6. When I do that, the left-hand side is x. My inequality symbol stays the same, and 24 divided by 6 is 4. So that tells me x is greater than or equal to 4. I create my number line. I'm going to put a 4 because that's what I'm comparing x to. And now I need to decide, am I going to fill in my circle or not? Well, x could be equal to 4, so I need to fill in my circle. And x is greater than or equal to 4, so I shade everything that is bigger than 4. Number 6 tells me to solve and graph. I've got k minus 7 is less than 9, so we'll draw our line through the inequality symbol. The opposite of subtracting 7 is adding 7. These cancel out, and I get k is less than 16, so we'll draw our number line. And I'm leaving out a bunch of numbers. But if it helps you to put in 17, 18, 15, like all of those, that's fine. You can do that. I know I care about 16. That's what K is compared to. I'm not going to fill it in because K is less than 16, and I will shade everything smaller than 16. 7 and 8 are problems for you to try, so if you want to flip them, you can. Remember to flip the inequality symbol. So 2p is less than 6. The bigger end is open to the 6. The bigger end is open to the 6. Pause here and come back to check your answer. When you solve that out, you end up with p is less than 3, so on our number line, that is an open circle, and we shade everything to the left of 3. Our next problem does have the variable on the right again, so if you want to flip it, you can. That gets us k plus 8 is greater than 3. Notice that the side with the variable gets the open end, so the side with the variable gets the open end. Go ahead and pause the video here while you solve it and graph it. When you solve that out, you get k is greater than -5, so I put my circle on -5. I did not fill it in, and then I shaded everything to the right of 5 because it is, or I'm sorry, to the right of -5 because it is greater than -5. All right, number 9 is an I do. It's pretty similar to the ones that we've done before, but we're going to be introduced to a new rule. So I've got m divided by -3 is less than or equal to 6. I'm going to draw my line, and I know the opposite of dividing is multiplying, so I'm going to multiply by -3, multiply by -3. These will cancel out and leave m. -6 times -3 is positive 18. And in inequalities, whenever you multiply or divide by a negative number, only multiplying or dividing with a negative number, you will flip the inequality symbol. Okay, so we went from less than or equal to greater than or equal to because we multiplied by -3. And then it graphs the exact same way. We care about 18. M is greater than or equal to, so you fill in the dot and shade it. Okay, so let's look at our next problem. -2 times x is greater than or equal to 24. I don't need to change, I don't need to flip-flop because the variable's on the left. So I'm going to do the opposite of multiplying by -2. I'm going to divide by -2. And that gives me x here and -12 there. And since I divided by a negative, I need to flip my inequality, and that tells me x is less than or equal to -12. So I'm going to put a -12 on my number line. Because x could be equal to, I fill in the dot, and I color everything to the left. So your job is to do number 11. Solve that out, press pause, solve it out, graph it, come back and check your work. Okay, we're back with the solution. Remember to flip your inequality symbol so we get x is less than 7. So when we graph it, we leave an open circle and we shade everything to the left. Number 4, if you want to flip-flop the side, or number 12, if you want to flip-flop the sides, you can. We get n divided by -7. The bigger end is open toward the variable, and that's being compared to 4. So pause the video here while you solve it and graph it, then come back and check your answer. Okay, welcome back. When we flipped our sides, that got us n divided by -7 is greater than 4. To undo division, we multiply, and because we are multiplying by a negative, that does flip our inequality. That gets us n is less than -28, so we do not fill in our circle and we shade everything to the left. I would like you to please self-assess and then fill in your reflection. What are the key things that you learned about solving inequalities today? What are the steps to solving them? What are the special cases? What did we just talk about? And then do your practice problems.